Hi everyone, this is Anand from Computer Science Department, PG and Research Department of Computer Science. I have taken the subject as Fundamentals of Algorithm in the unit of second, and I am taking the topic of Traveling Salesman Problem. The Traveling Salesman Problem. The Traveling Salesman Problem, it is a classic optimization problem, where a salesman is required to visit a set of cities exactly once, starting and ending at the same city. Because if the salesman start the which place they have start, it will be they will come back to the ending place. Ending place and starting place is the only one city. Like A, B, C, D. There is a is our one of the city, and B is the one of the city, and D is the one of the city. If the salesman starts from A, means it will ended in the A, because it will be one of the circle, like a circle, while minimization the total distance or cost of the trip. The main thing is we have to minimize the distance, and also we have to reduce the cost for the trip for the traveling salesman problem. It is a well-known NP-hard problem in combination of optimization, meaning there is no known efficient way to solve it for large number of cities. Problem statement: given a list of cities and the distance between each pair of cities. That means we give the log of distance is there, like A to B, B to C, and C to D. Like that, there are many distances are there. We have to combine the pair of cities. Like A to, if we start from A, means it will move to A to C, or A to B, or A to D, like that. The task is to find the shortest possible route that visit each cities exactly once and return to the starting city. That means we have find the possible route to the maximum of minimum of the cost. That is the thing. Example, let consider a simplified version with 4 cities like A, B, C, and D. We can represent the distance between these cities in a matrix way. That means we have calculated the values. This is the simple matrix way, like A, B, C, D is the city from place, and 2 also where we go to from the source is A, B, C, D, and also destination is the A, B, C, D cities. That is A of 1 is a 0, because we start from A, and A of B is the 10. That is where we move to. Where we move to the places A of B is 10. A from A city to B city, it will the distance of the area is 10, and distance is A to B, and the cost is 10. And another thing is A to C. From A city to C city, the minimum cost is 15, and A to D city, the minimum cost is 20. Likewise, the B to A is 10, and B to B is nothing, and B to C is 35, and B to D is 25. Like C to A is 15, and C to B is 35, and C to C is 0, because that is a starting way, and C to D is 30, and D to A is 20, and D to B is 25, and D to C is 30, and D to D is 0, because it is the starting way. So likewise, it will be move on one by one, it will goes on. So from the starting source to and ending destination is the same. If we go to A to B, and A to C, and A to D, and also B to E, and B to A, and B to C, and B to D, there are many ways are there. We have to identify which is the best minimum cost. We have to identify that. Here the distance from the city A to A, distance from city A to city B is 10, and the distance from the city A to city C is 15. Likewise, this is the way we have to move. This is the way we have to move, and this is the possible route for traveling salesman. The salesman can take several routes. For example, from A city to city B, and city B to city C, and city C to city D, and city D to city A. That means the traveling salesman starting from the A city and ending from the city A. Likewise, there is a second option also is there. From the city A, it moves to city C, and city C to city B, and city B to city D, and city D to city A. There are three ways of there. So each way is moving on. So now we see how it is working on. For each route, the total distance is sum of the individual legs. That means individually how it will be calculated like that. Let's calculate the distance for some of the routes. Like we can take the route 1, that is city A to city B, city B to city C, city C to city D, and city D to city A. That means A to B is value of 10, and B to C is value of 35, and city C to city D is value of 30, and city D to city A is 20. The total distance is 10 plus 35 plus 30 plus 20 equal to 35. This is the route number 1. And there is a route number 2, that is goes to city A to city C, and city C to city B, and city B to city D, and city D to city A. That is A to city A to city C is 15. City C to city B is 35. City D to city D is 25. City D to city A is 20. The total distance is 15, 30, 25, 20. That is equal to 95. This also one of the value is given as 95. The two routes are giving the value of same value. It is the minimum cost of the value. We take only the pair of cities like A to C, like C to B, like D to A, because each pair is given as a shortest path. We have to easy to identify with the pair of each cities. And this is the route 3. There is a third route also is there. We have checked the first route is A to B, and the second route is A to C, and the third route is A to D. We start from city A to city D, city D to city B, city B to city C, and city C to city A. That is A to D. City A to city D is 20, city D to city B is 25, city B to city C is 35, city C to city A is 15. The total distance as 20 plus 25 plus 35 plus 15 equal to 95. This is the minimum cost. For each route, there is a first route, second route, and third route. Every route has the same value, 95, 95, 95. So we analyze this is the shortest distance, and we can take any one of the distance. All distance are the same value. All distance are the minimum cost. So we can take any one of the route by the way of this simple matrix. We can take this from source to destination, from the A to A, and we move to the. In this simplified example, all these routes given the same distance. However, in general, different routes may have different cost, and the goal is to find the shortest possible route. The main goal is to find the shortest possible route to analyze the minimum cost and analyze the distance. In this problem, every route has the same distance. Exact algorithm to solve the traveling salesman problem. There are three algorithms are there: brute force, dynamic programming, approximation algorithm, that is nearest neighbor, finders algorithm, and genetic algorithms are there. We have take the dynamic programming. The held cap algorithm reduce the time complexity, but still exponential in nature. This is very useful for to identify the traveling salesman and identify the minimum cost. So we take the dynamic programming algorithm. And this is the application for traveling salesman problem. There are many applications. There are three applications I have identified. That is logistics and routing for delivering service such as UPS for FedEx to find the shortest path for package delivery. And manufacturing, there is another application is there. Optimizing the movement of machines or tool in a factory, and genomics is it's a way of identifying the DNA sequencing problem can be mapped to the traveling salesman problem. Thank you.